Guys, the sub should have returned to you this handout. This really is about the margin of error. This is where we did a simulation about can you tell the difference between the Kroger generic and the Dasani water? And we were using this simulation in order to build the margin of error so that we could finally make a conclusion. Can students really identify the difference, or is it possible that we're just guessing randomly? So this is out of 14 points. All of the ideas here are important for your test tomorrow. You'll find almost everything here is also on the review that you're about to work on. So in question number 1, if you want to simulate the 57%, the 57% success rate that we saw in our experiment, then the numbers 1 to 57, those would represent a student that identified the different water correctly. And when we did this in class, then the numbers 58 to 100, those represented the students that didn't identify the different water correctly. So this was the simulation. This is exactly your graph that you plotted during class. So every one of these dots represents a simulation of 14 students. Those 14 students had a 57% success rate of detecting the different type of water. So we had a simulation where even though their success rate was assumed to be 57%, it just so happened by random chance alone, only 3 out of the 14 successfully identified the different water. We also had one simulation so extreme that 12 out of the 14 were able to identify the different water in that simulation. Of course, it shouldn't be much of a surprise. So typically we're getting 7 or 8 students, around half, a little more than half, around 8, that are identifying the different type of water. And that's exactly what should be happening, because in our simulation, we assumed that the success rate was 57%. So you had to do some calculator strategies in order to convert these data on your calculator, which these are the success counts. We had to calculate the percentages that correspond to them. So all of these values were in list 1. So we had to take every value in list 1 and divide it by 14 in order to turn it into a percentage, or either a decimal value. And then we stored those values back into list 1. And then your job was to run the one variable statistics command on list 1 so that you could find the mean and so that you could find the standard deviation. So everybody should have gotten a mean of 57.3%. So that's good news, because we simulated based on an assumption of a 57% success rate. So indeed, the 57%, that quote, truth, is really ending up in the middle. And what's really important for us was this: we needed the simulation in order to calculate the standard deviation of 13.7%. So to get the margin of error, you take the standard deviation and double it. So that's the 27.4%. So that was worth 3 points, 1 point each. Now, we've done number 4 a number of times. We did a number of examples in class, and I really do expect you to write this specifically and write in context. So the margin of error, we're trying to come up with a range that tries to capture the truth. We'll describe that truth. We're trying to capture a percentage, and it's a percentage of what? Of students that can identify the different water. So somewhere in your answer, you had to say percentage, and in context, it's the percentage of students that can do this, that can identify the different water, and I wanted you to give me the boundaries. So we have evidence that that percentage is within 27.4% of our result of 57.1%. So to get these boundaries, all I did was take the 57.1%, not the mean from the simulation, but I took the actual value that we observed in our experiment, 57.1, and I'm adding to it and subtracting from it the margin of error. So here's the 57.1 minus the margin of error. Here's the 57.1 plus the margin of error. So the true percentage of students at our school that might be able to identify the different water, we think it could be as low as 29.7% or as high as 84.5%. So there were 4 things that I was looking for there. Then question number 3 is probably the most important part. So if you consider how we interpreted the margin of error, do we have evidence that students are able to identify the different water and they're not just randomly guessing? Well, remember, there were 3 cups presented. One of them is different. A 1 out of 3 chance is 33%. If students are just randomly guessing which cup has the different water in it, they'll be right 1 out of every 3 times. They'll be right 33% of the time. Well, notice 33% is actually captured within our margin of error. Now, I know we have a humongous margin of error, so we have a very wide span of where the truth might be. So having said that, this span captures 33.3 repeating percent. It captures the percentage that suggests that maybe people are just randomly guessing. So the correct answer to number 5 is no. So, but then tell me, why do we not have evidence that students can identify the different water? So, well, that's because maybe people are just randomly guessing. If students are randomly guessing, they'll be correct about 33% of the time, and that value is actually found within the margin of error. That value is actually found within this span that we interpreted in question number 4. That 29.7% is our lower boundary. The 33% is actually higher than that. Random guessing, 33%, is a candidate for the truth. It's a possibility for the true percentage that can identify the different water. Maybe people are just randomly guessing. So, of course, one of the problems here is we have a huge margin of error. That's because we had such a small sample size. We only had 14 students that participated. So in question number 6, if you want to decrease the margin of error, you need to get a larger sample size. You need to increase the sample size. And then the last question, if you double not the number of participants in each simulation, but if you doubled the number of simulations, so literally, instead of doing 70-ish simulations here, if we doubled it and did 140 simulations, will that change the margin of error? And the answer is no. So we will still have a margin of error that's about the same as what we've already observed. I might have more simulations, so I might be, that margin of error may be more trustworthy, but it's going to be about the same. By doing more simulations, I can't guarantee a smaller margin of error. By using more students in each simulation, however, that will give me a smaller margin of error.